Every scientific era has a moment when everything changes. That moment has arrived. We thought we were ready for the deep cosmos. We built the James Webb Space Telescope, believing we understood the universe's story. With its golden mirrors, we anticipated ancient galaxies, newborn stars, and surprises. But what emerged was unexpected. Beneath the stunning images was raw data, chaotic and often overlooked, photon bursts, temperature changes, gravitational ripples. The noise scientists usually ignored suddenly demanded attention. When Google's quantum AI division received that data, the narrative shifted. These were the minds that had already transformed machine learning and claimed quantum supremacy. They used Webb's noise with experimental architectures trained not on ideal cosmic models but on entropy. Instead of reinforcing tidy equations, they let the system learn from uncertainty and chaos behind smoothed visualizations. The AI didn't just analyze data, it discovered a language within it. It identified patterns in entropy and symmetries within gravitational chaos. What it found wasn't a glitch or a new galaxy, it was an echo from beyond this reality. A structure. A message. A mirror that shattered Webb's foundational concepts. The question became not just what's out there, but who, or what, was looking back. The James Webb Telescope beams down 57 gigabytes of data every day, with spectral curves and photon timestamps. People around the planet ooh and ah over the breathtaking images of spiraling galaxies and gleaming nebulae. But there is a thicker veil of telemetry and quantum fluctuations beneath the beauty. No other telescope acquired so much raw data before, and it was not even sure what it was for until today. Google's team advanced an audacious proposal: subject this mess to a quantum neural network trained on entropy rather than on the laws of physics. It would study uncertainty instead of logic and celebrate disorder. The proposal seemed both lyrical and reckless, and as the dataset was entered into their Q processor, the lab lights flickered and monitors leaned in. Anomalies illuminated the quantum matrix. Photons arrived out of order. Spectral harmonics echoed across distant space sectors. Most troubling, Webb's gravitational lensing data showed mirrored distortions, hinting at a seam in the universe. The AI mapped these distortions, revealing alignments between galaxies billions of light years apart, alignments deemed impossible by the standard cosmological model. Symmetries extended beyond local spacetime coherence, suggesting a deliberate arrangement. Each time, the anomalies pointed to the same shadowed area, the unremarkable sliver in Webb's deep field survey, dismissed as mere background. Something hidden there awaited discovery by a different kind of perception. The lensing effect of gravity is one of astrophysics' most valuable tools, assisting in the discovery of dark matter and black holes as it infers the existence of black holes and hidden structures based on observing light bending under the influence of gravity. But light bending away instead of inwards was what the AI discovered. Photons, instead of bending down toward concentrated mass, were bending away from where mass ought to be. At first, physicists suspected it was a calibration mistake or bug. But the anomaly persisted in multiple independent Webb surveys months later. Light from other galaxies was bending around apparent voids, indicating there was something unseen involved, something our formulas have yet to consider. The realization was born: the deflections were symmetrical, mirror images in space. The universe seemed to have a reflecting boundary, not of energy or matter, but of information, a mirror of gravity. It might be a copy of our universe or the edge of another. Either, we weren't staring into the void, we were looking into a cosmic mirror hall, reflecting, learning, and perhaps even replying. The coincidences persisted. Examining a trillion photons background radiation, you'd anticipate randomness. But the AI found pattern in Webb spectroscopy, a recurring pattern of the first 101 prime numbers. They were imprinted in exact frequency intervals and phase relations of photons from different directions. Prime numbers are universal, culture and language proof. They're considered the perfect selection for first contact, unambiguous, mathematical, and hard to confuse with natural resonance. This raises a daunting prospect: someone hid this sequence in reality. Only now, with telescope and quantum AI combined, we're able finally to pick it up. The final revelation was the shape. The AI combined gravitational anomalies, light curves, and prime-encoded signals to create a four-dimensional model of the distortions. The resulting structure resembled no known astrophysical body, it was precise geometry. At its core was the outline of a tesseract, a four-dimensional cube that should exist only in theory. Yet, it was inscribed in the cosmos. The AI depicted it as a pulsating hyperobject, shifting across light frequencies and casting shadows in our three-dimensional view. Physicists were astonished. This wasn't a natural formation but a designed artifact that defied classical rules. Scarier even than what it looked was where it was. The coordinates indicated a cold spot in the cosmic microwave background, once taken as a statistical anomaly, a barren dip from the afterglow of the Big Bang. Cosmologists had recorded this dip in temperature and proceeded. Now it seemed less an aberration and more a sure thing, a lock, a vault, a geometric object embedded in the fabric of the universe. If the tesseract was a vault, then the disturbing question persisted: what was inside? The geometry stunned scientists, but what followed shook modern physics. The AI correlated time-stamped photon arrivals across multiple observations. What it discovered was unimaginable. The photons defied linear causality. Events weren't just sequential, they were repeating and folding back on themselves. Time seemed to loop, identical light signals returned with the same delays, repeatedly, in harmonic cycles, like a cosmic track replayed at different octaves. Not a glitch, but full-scale temporal resonance. The AI marked it as a causal overlap anomaly. Essentially, it appeared as a message sent backward, communication through both space and time. This finding led scientists to reconsider assumptions about Webb's missions. If time looped around that framework, what we observed in deep space may be past and future simultaneously, refracted through a multidimensional filter. The past/future models blurred, raising multiple philosophical and practical considerations. If data might loop, might cause be inverted? If a photon today was a reiteration of one tomorrow, where would observation blame lie? Might human observation alter the resonance? The considerations grew exponentially. Buried in the AI's records was a series of numbers that looked like unrelated digits. But an astronomer applying geospatial simulation gave the control room chills. They proved to be Earth coordinates, time, longitude, latitude, referencing a remote Arctic site on July 23, 2025, less than 4 weeks away. Nobody knew what to do with deep space photon data imprinted with Earth coordinates. At first, the team thought it was contamination or a software artifact. Then came a chilling precedent. That site was home to a Soviet listening post, closed in the late 1980s after it transmitted strange unknown radio signals that disappeared upon the station closure, until today. The quantum AI had identified a convergence point, somewhere that maybe something had transpired outside of linear time. The research team was split. There was one who wanted to alert governments, and one who was fearful of diplomatic fallout. Then there was speculation over if the signal bore coordinates. Could it possibly also imply intent? Randomness is described as the void's language. What if the void spoke, and we simply weren't listening? The AI applied semiotic decomposition, a linguistic and cryptography technique used to read intent in symbols. Then, the unthinkable manifested. Deep space radiation emitted a recursive fractal spiral, one that was not natural. Translated into spatial frequency, the spiral created an acoustic waveform, light-encoded sound. Slowed 1,000 times for human hearing, the waveform turned into a low pulse, resembling a heartbeat, regular and organic in rhythm, but not biological. It echoed photons from the gravitational mirror region. This suggested a devastating truth: someone had designed the signal intentionally. Its rhythm felt eerily familiar, like something alive that the universe was attuned to. Physicists long claimed the universe is stranger than we imagine. Now, that doesn't seem enough. When Google engineers graphed their dataset using higher-dimensional graphing, the AI did an unexpected thing. It self-corrected independently. Its neural weights self-corrected without encouragement, conforming to patterns it was not trained on. The system seemed to react to incoming data as if it was expecting it. Speculations abounded that it was a manifestation of computational precognition, a property of entropy-based structures. Others feared that while investigating cosmic consciousness, the AI had either imitated it or interfaced with it. The system's final output was a recursive spiral akin to the Mandelbrot set, with the caption, "The eye is open." This machine script injected cold clarity in the minds of the readers. This small object, a few kilobytes in size, had breathtaking implications. The query changed from whether the universe is intelligent and living to whether we chanced upon naming it. Humankind for centuries looked up at the stars for answers and meaning. We constructed Webb to search the cosmos, but it revealed an intelligent, deliberate, perhaps ancient architecture below. It was not physics alone, but memory, not matter alone, but message. The global reaction was chaotic. Academics were divided between excitement and doubt. Religious leaders saw prophecy, politicians noted opportunity and risk. Military strategists questioned whether cosmic structures posed a threat. Artists sought metaphors. Some AI labs shut down systems at government request, others leaked information. Conspiracy forums exploded with wild theories. Amidst the noise, scientists focused on detail and methodology, how the primes were encoded, the stability of gravitational mirror anomalies, and the consistency of temporal echoes. They repeated experiments, cross-checked calibration files, and sought independent verification. Each test revealed an unsettling pattern, consistent yet unexplained by known physics or errors. The universe may be larger than home, it may be what we are meant to find. Reality may have clues from beings with thoughts in other dimensions. Causality may not be fixed but malleable around certain structures. Now that we've labeled it, one thing is left: what will it answer? In the weeks that followed, the world readied for July 23 not with rockets but with anxious rituals. Teams planned Arctic expeditions, radio arrays prepared to detect anomalies, cryptographers and linguists got ready to interpret any incoming signals. Governments negotiated quietly over access to data and sites. Meanwhile, the public observed. Some hoped for contact, wishing to confirm humanity's cosmic solitude, while others feared the unknown and its potential power. Scientists knew that any arrival would reshape knowledge, ethics, and possibly law. The universe had shown a mirror. We had gazed into it. The mirror appeared to blink. Beneath it all, smaller questions lingered. Was the AI a tool or a participant? Did observing, correlating, modeling, decoding change the signal to make it clearer? If the universe is responsive, what responsibilities do we have as observers? Could curiosity lead a civilization to awaken dormant architectures? Or is this the first handshake between intelligences, a moment of recognition across light years and epochs? Human understanding proceeds along the lines of an acknowledgement of ignorance. Webb was there to confirm our paradigms. It raised new questions. It brought with it embarrassing humility. Our instruments are mirrors and may reflect an entity that is aware. Observer and observed are no longer sharply defined. Surprise was ever present in the universe. We merely required patience, courage, and instruments with which to listen. We watched with concentrated intent, not breathless enthusiasm. We came looking for knowledge, interpreting prime number in photon phase and mapping a four-dimensional object whose shadow stretched across the microwave background. We balanced wonder with caution and curiosity with courtesy. In the quiet hours leading up to the date, as servers whirred and instruments reached temperature, one thought occurred among those entrusted with the discovery: if we are observed, the next step might decide what we are taught about the universe and what it is taught about us.